Welcome! Here we are going to see an example of the chain rule for functions of several variables. And by several, I mean two in this easy example. Okay? So a practical example, in the previous video we saw the theory. Now let's put some concrete functions here. So my function x that takes real numbers in R2, vectors in R2, my function is just the function x of t equals t, comma, t squared. Okay? So x1 of t equals t is the identity function, x2 of t is t squared. The derivative of this function, I take the derivative of this with respect to t is 1. The derivative of t squared equals 2 times t. Okay? Derivative each coordinate at a time for the vector function x. Okay? Now, for the function f, for the function capital F of x1 and x2, remember, function capital F pick vectors of dimension 2 and takes into real numbers. So the function f is just the product of x1 and x2, the product of the two coordinates, right? In particular, the partial derivatives are, partial derivative with respect to x1 is x2, and partial derivative with respect to x2 is x1. And we know x1 of t is t and x2 of t is t squared, right? By the definition of function x, right? So now I will apply my chain rule, my formula. It's going to be partial derivative of capital F with respect to x1, t squared, multiplied by x1 prime, the derivative here of x with respect to t, x1 with respect to t is 1. So this is partial derivative of f with respect to x2 is t. So this is t here, the partial derivative, times x2 prime is 2t. Remember, x2, the function, the second coordinate was t squared, the derivative is 2 times t. Okay? Then t squared times 1 is t squared, t multiplied by 2t is 2t squared plus twice t squared is 3 times t squared. Okay? So this is my derivative of the composite function. Okay? Derivative of the composition with respect to t is just 3t squared. That's my final answer. Of course, we could have done in the natural way, first computing the composite function, right? The composite function, we just take the product of the two coordinates. So the coordinates of x are t and t squared. We make the product, t times t squared, t to the power 3, and we take the derivative of this with respect to t. What's the derivative of t to the cube? It's going to be 3t squared. Exactly what we found here. Right? So anyway, you could apply the formula or you could find the composite function and then take the derivative. Either way, you should get the same answer. Alright? I hope it's very clear and this example helps you. See you next time. Thank you.